Hello students, I hope you all are fine. Students, today we will discuss some important points based on the modern periodic table. Okay, students, this one is the modern periodic table which one we are using these days. So there are total 118 elements. There are total 118 elements in modern periodic table. Students, in our modern periodic table, there are 18 groups. There are 18 groups. You can see 18 groups. What do you mean by the groups? Groups, these vertical columns, these are the groups. Okay, so here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. These 18 vertical columns are known as the groups. Okay, so in our modern periodic table, there are 18 groups. Okay, and students, there are 7 periods. First one is this, in which only 2 elements, hydrogen and helium. In second period, there are lithium to neon. It is lithium to neon. There are 8 elements in this. There are 8 elements in this. Then students, in third, also there are 8 elements, sodium to potassium, sodium to argon, sodium to argon. Then students, this is our 1, 2, 3, and 4. In fourth period, potassium to krypton. Krypton is the last element of this. Okay. Then fifth, sixth, and seventh. So there are total 7 periods. There are total 7 periods in our periodic table. So students, in periodic table, 18 groups and 7 periods. Seven periods are there. What do you mean by periods? The horizontal rows. The horizontal rows. These are known as the periods. Students, I have told you that there are total 118 elements in periodic table. So now there are 7 periods. In first period, only hydrogen and helium. Only 2 elements are there. Only 2 elements are there. In second period, so lithium to neon. 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there. In third one also, sodium to argon. There are further 8. Okay. Then students, in fourth period, there are 18 groups and it is completely filled. So there are 18. There are 18 elements. In fifth one also, there are 18 elements. But students, here, in sixth period, these two series, okay, these are also included in these. In sixth period, this lengthenoid series is included. So here total 18 plus 14 of these, plus 14 of these. So in sixth period, total 32 elements are there. In sixth period, total 32 elements are there. And in seventh also, these 18 plus 14 of actinoid series. There are also total 32 elements. Okay. So students, there are total 2 plus 8, 10. 10 plus 8, 18. 18, 18, 36. And 18, 54. And these 64. So 64 plus 54. There are total 118 elements in modern periodic table. Clear or not? Yes. Then students, in modern periodic table, It is divided into 4 blocks. It is divided into 4 blocks. Group number 1 and 2 elements, they are known as the S block element. Group number 1 and 2, this is S block. And students here, group number 3 to 12, 3 to 12, it is known as the D block. And here, group number 13 to 18, group number 13 to 18, 13 to 18 is known as P block. And student, these two series, this one and this one known as lanthanoid series and actinoid series, and combinedly they are known as F block. Then students, why they are known as S block, P block, D block and F block elements? It is based on their configuration, in which last electron means is present. Okay, last electron is present in which orbital? According to that, block is allotted to them. Clear or not? Like student, we can see here 4 block first. For S block, here general configuration will be, for S block, your general configuration for S block, general configuration will be NS122. Clear? Like students, you have seen here in group number first, elements are hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Then students, you can see here, if I talk about hydrogen, then how many electrons are there? 1. So its configuration will be है कि से फरियाद. This is group number first. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Then student here lithium. Lithium has atomic number 3. Then you can write down electronic configuration for that, 1s2, 2s1. Then in sodium. Sodium has atomic number 11. Then here 1s2, 2s2, 2p6, 3s1. You can write for other also. So I think you are able to see here last electron means valence electron is present in s orbital. Clear or not? So student, here last means valence electron is present in s subcell. So on behalf of that, we give name to the block. Okay, like student, you can see example of any group number 2 element. Like we can take calcium. Group number 2 elements are beryllium. After that, magnesium. Beta, mange, car, scooter, bap, raji. In this way you can learn. Beryllium, magnesium, calcium, strontium, barium, radium. Beta, mange, car, scooter, bap, raji. Okay. So student, here let us consider I take this one. This is calcium. So what is the electronic configuration for calcium? 1s, 2s2. Okay. 2p6, 3s2, 2, 4, 10, 12, 3p6 and 4s2. So here also you can see, here outermost electrons are present in s subcell. So it is also element of the s block. So students, this one is the general configuration for s block elements. If your element is present in group number first, then there will be 1 electron in outermost shell. And if your element belong to the group number 2, then there will be two electrons. There will be two electrons. It is clear to you or not? Yes. Then student, if I talk about the p block, it is known as p block because here electrons, the outermost electron will lies in p orbital. What will be the general configuration for p block? It will be ns2 np126 np126. This will be the general configuration for that. Students, group number 1 and 2 elements are s block, and group number 13 to 18 elements are known as the p block elements. P block elements. Like students, you can see boron, like this one is group number 13. Boron, aluminium, gallium, iridium, thallium. Okay, these. So students, in boron, bangan, aloo, gajar, in thali. In this way you can learn. Bangan, aloo, gajar, in thali. In this way you can learn. So students, if I talk about configuration of this is boron. Boron, what is the atomic number for boron? 5. So atomic number for boron is 5. So here write down configuration for this. What will be the configuration? 1s2, 2s2, 2p1. And if I talk about neon, here neon is 10. Then 1s2, 2s2, 2p6. So students, here n is this. This is n. So np, 1 here, and this one is n. So ns2. Okay, here also ns2 and np6. So in both you can see, in s subcell there are 2 electrons only, but in p subcell electron may vary from where? From 1 to 6. So this one will be the general configuration for p block elements. Any doubt in this? Yes. Then students, if I talk about the d block elements, in p block elements, this group number 18, this group number 18 is known as the noble gas. This group is known as the noble gas. Why it is known as the noble gas? Because here outermost shell is completely filled. Outermost shell is completely filled. Clear or not? So students, it is extra stable. So it is known as the noble gas. Group of elements of these groups are also known as inert gases. Okay. Then students, if I talk about elements of group number 17, these are known as the halogens. These are known as the halogens. And students, group number 16 elements, these are known as the chalcogens. These are known as the chalcogen. And group number 15 elements, these are known as nitrogen family, this one carbon family, and these are known as the boron family. Clear or not? Yes. Student, in this p block, metals, non-metal and metalloids, okay, may be found. This one, the elements which are on borderline, these are the metalloids here. These are the metalloids here. What do you mean by the metalloids? Yes, which shows the properties in between the metals and non-metals. These are also known as the semi-metals. Okay, students. So in B block, there may be some metal, non-metals and metalloids also. Then if I talk about this group, this block, this one is the D block. D block is also known as the transition. Here metals exist in this block. So students, elements of these are known as the transition elements. Okay, but students, here zinc, cadmium, mercury, these are not transition element. Why they are not? Because transition element are those which has partially filled d orbital, here if we will write about configuration about zinc, cadmium, then we will find here in case of zinc, d orbital is completely filled. There are 10 electrons, okay, in d orbital. So students, here d orbital is completely filled, so it cannot be considered as transition element. Clear or not? Then what will be the general configuration for this? For p block elements, we have written. Now we will write general configuration for d block. It will be n minus 1 d 1 to 10 ns2, n minus 1 d 1 to 10 ns2. Students, you can see, if I talk about first element of d block, this is scandium, its atomic number is 21. If we will write configuration for this, then 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. You can count 2, 4, 10, 12, 18, 20 and 21. Students, here n is this bigger number. This one is n here. Okay. So n minus 1 means 4 minus 1 will be 3. So here you can say this is n. So 4 is 2. And in D, this is n minus 1 means 3d. Clear or not? So student, here configuration will be n minus 1 d1 to 10 electrons may be there. And in ns2, but some exceptions are there. Some exceptions are also there. Like students, if I talk about chromium 24. Okay, if I write configuration according to the rules, then it should be like this. It should be like this. But students, we do not write in this way. Here configuration for chromium is in 3D we fill 5 and in 4S we fill only 1. Okay, why it is? Because here d orbital is half filled, and half filled and completely filled orbitals are extra stable as compared to the partially filled. Okay, so students, some exceptions are there, but in most probably cases we write the configuration in this way: n minus 1 d1 to 10 ns2. Clear or not? Yes, I hope this is clear. So students, in this, there are 4 series. This one is known as 3D series. This one is known as the 3D series. Only scandium to zinc. This is known as the 3D series. Okay. Then students, this one is known as the 4D series. Ytterbium to cadmium. Clear? After that, this one is 5D series and this one is 6D series. So there are 4 transition series: 3D, 4D, 5D and 6D. Why it is known as 3D? Because here electron is filled in 3D orbital. So it is known as the 3D series. Okay students, here these are known as the transition metals, and these lanthanoids and actinoids, these are also known as the inner transition metals. Why they are known as the inner transition metal? Because students, here after lanthanum, 58 to 71. Lanthanum is 57. Lanthanum is 57. And then hafnium is 72. In between them, 58 to 71. 58 to 71. 58 is cerium and 71 is lutetium. Clear or not? Students, it is including between transition series. So it is known as the inner transition metals. They are known as the inner transition elements, we can say, because most probably elements are metallic in character here. So we say metals. Clear or not? And students, here, this one, thorium. Here actinum. Actinum is 89. After that, this is RF, it is 104. Then in between 90 to 103. 19 to 103. These are the actinoids. So these are also exist here in between the transition elements. So these are known as the inner transition elements here. Clear or not? Students, here we not include lanthanum in F block because here series is starting after lanthanum. So they are known as the lanthanoids. It doesn't mean also included in lanthanum is also included. No, lanthanum is not included in lanthanoid because after that this series is started. So they are known as the lanthanoids. Clear? And after that actinum, this series is starting. So we say this one actinoid series. Clear or not? Yes. Students, if I talk about the D block elements, so typical metals are present here. Typical metals like you tell about the properties of metal, they are malleable, they are ductile, they are sonorous. Means typical metals are present here. They show maximum all properties of the metals. But student, if I talk about the exception, then you will get exception in group number 1 and 2 in S block elements. Clear or not? Yes. Then students, these have variable oxidation state also. These have variable oxidation state also. For example, if I talk about manganese. Manganese atomic number is 25 here. Manganese atomic number is 25. Then students, I can write 1s2, 2s2, 2p6, 3s2, 3p6. After that 4s2, 3d5. Students, here after removing 7 electrons, it can get configuration of a noble gas, that is argon. Okay, so its oxidation state may be 1, not 1. Maximum transition element exists in 2, 3, 4, 5. So it can maximum 6. It can attain maximum 7 oxidation state here. Okay, so in these, it can exist in Mn2 plus, in Mn3 plus also, 4 also. Means its oxidation state may be vary from 2 to 7. 2 to 7. Clear or not? So D block elements, they have variable oxidation states. Student, they have tendency to form complex. Okay, they form interstitial compounds also. Clear or not? So this, if I talk about the properties, this is all about the periodic table. How many elements are there? How many periods are there? How many groups are there? Okay, how many blocks are there? And what is the general configuration for different block? Okay, then for F block, what will be the general configuration for F block? For F block, students, general configuration will be N minus 2, F1 to 14, N minus 1, B 0 to 1 and NS2. So students, this may be the general configuration for F block element, for F block elements. Clear? Here students, if we will discuss about the properties like atomic size, ionic atomic radius, electronegativity, electropositive character, metallic behavior, non-metallic behavior, what will be trend. Okay, so students, we found that here fluorine is most electronegative element in periodic table. Fluorine is most electronegative element in periodic table. Okay, and here this cesium is most electropositive metal in periodic table. Okay, but student, if I talk about more electronegative is fluorine, but maximum electron affinity has chlorine. Okay, so in next video we will discuss about the properties, their trends. Okay, I hope this is clear to you. So thank you, have a nice day.